All right, so this video starts Unit 5, and Unit 5 is all about polynomial functions. So basically, what I want you to know for Unit 5.1a is I want you guys to be able to use your exponent rules to simplify monomial expressions, and I want you to be able to classify the degree and the number of terms of a polynomial expression. So first, we have to talk about monomials. So a monomial is a singular real number, a variable, or a product of real numbers and variables. The only thing is for our final answer, we cannot have the exponent as a fraction or a negative. So some of our examples of a monomial, you have something like 3x. You may just have a number like 5. You may have multiple variables in a term, so something like 2xy. You may also have something like 4x squared y cubed, because this is still considered one term. So next, we're going to kind of get into our exponent rules, and these are ones that we've kind of talked about as we've gone through Unit 4, but now we're really going to get into the details of how these exponent rules work. So our first one is the zero exponent rule, which a to the 0th power equals 1. A really just represents any variable or number. So an example of this is just x to the 0 equals 1. Pretty simple. When we're moving on, we have the product rule. So if we have a to the m times, times a to the n, our product is going to be a m plus n. So if we want to see an example of this, if we have something like x cubed times x to the 5th, our answer is going to be x to the 8th. This is a 5. Just want to make that a little clearer. X to the 5th. So when we multiply two variables or two numbers with different exponents, we add the exponents together. So multiplying, we add. With dividing, we're going to do the opposite. So we have a to the m, or a to the n, over a to the m equals a n minus m. So again, if we want to see this, let's say we have something like x to the 6th over x squared. This is going to be 6 minus 2. So we have x to the 4th. If I am moving too fast, remember you can slow me down or pause and go back. So then we have a power of a power rule. So basically, if we have a to the m, and then we take that to the nth power, so let me just kind of fix that a here. Then we are going to multiply m and n together. So we have a m times n. So again, if we want to see like this with actual variables, let's say we do x cubed, and then we square it. So we're going to multiply the 3 and the 2 together. This gives us x to the 6th. We also have the power of a product rule. So if we have a times b in parentheses, and we take it to the m power, we really need a to the m times b to the m. Let's take that back a few steps. A to the m times b to the m. There we go. That looks a little better. If we're looking at this, we may have xy squared. This will equal x squared times y squared. So those are most of our formulas so far. We want to go ahead and scroll down just a little bit. So if we're looking at our negative exponent rule, we have something like a to the negative m equals 1 over a to the m. So again, looking at actual variables, we have x to the negative 2 equals 1 over x squared. I know this isn't the prettiest looking, but I'm not working with a mouse. I have a tablet here that I'm attempting to work with. So some of the rules that we need to know: when adding or subtracting, you can only combine like terms. So exponents and variables have to match exactly. When multiplying or dividing, you can combine different terms. Exponents and variables don't have to match. So for our first one, we're multiplying, and our first step is to multiply our coefficients together. So we have 3 times negative 2, which is negative 6. And we have x squared times x cubed. So remember, when we multiply exponents, we're adding them together. So this ends up being x to the 5th. We have negative 6x to the 5th. For number 2, the square gets distributed to each term. So 4 squared is 16. X squared is just x squared. Y to the 4th squared, when we have an exponent to another exponent, we need to multiply them together. So that becomes y to the 8th. After that, we can also divide terms. So again, we want to look at each individual term first. So 55 divided by 11 is 5. A cubed divided by a, this is really a to the 1st. So that would give us a squared because we subtract them. Then we have b to the 5th divided by b squared. So again, we subtract the exponents, giving us b cubed. Number 4, it's similar to number 1, but now we have a negative exponent, and we don't have to do anything with it right now. But if we get an answer with the negative, I'll show you what we need to do. So we have negative 2 times 5, that's negative 10. C to the 4th times c to the 9th. Remember, we're going to add these exponents together. So that would give us c to the negative 5th. But as I said earlier, we do not want a negative number as our final answer. So we're going to leave negative 10. C to the negative 5th should go into the denominator, just like our negative exponent rule up here. So what we're going to do is we're going to leave negative 10, and then we're going to flip c to the denominator. So that becomes c to the 5th. So it's negative 10 over c to the 5th. Our next one, let me go ahead and scroll down a little more. Scroll down a little too far. Let me get back up. Okay. So now we have something to the negative power. So again, when we have parentheses to an exponent, we need to distribute the exponent to each term. So what I'm going to do first is I'm going to say 2 to the negative 1 times s to the negative 3, because these are being multiplied together. We don't like seeing the negatives. So we're going to flip it. Anything that has a negative, we're going to flip to the bottom. So we have 1 over 2 to the first times s to the third. So really, if it's to the first power, we don't have to keep it there. So this is 1 over 2s cubed. Number 6, it gets a little more complicated. We're going to start to try and add these monomials together. So we're looking at our first one, and we need to do our division first, and we need to do our multiplication first. So let's worry about this. We have 4 over 5. Well, that's going to leave us with a fraction. So that's still 4 over 5. Then we have a to the 7th divided by a to the negative 3rd. So again, when we divide, we're going to subtract our exponents. So 7 minus negative 3 is really a to the 10th. While we're on this step, we also need to go ahead and multiply these two together because we don't subtract or add before we multiply. That's the order of operations. So 2/5 a to the 6th times a to the 4th gives us 2 over 5. We add our exponents, so a to the 10th. Then we haven't done anything with this one yet, so minus 1 over 5 a 10th plus. Now we just read them in order because all of these have the same exponent, so we can add them. So 4 over 5 a to the 10th minus 1/5 a to the 10th gives us 3/5 a to the 10th. Then when we add 2 over 5, we get 5 over 5 a to the 10th, which this fraction simplifies to 1. So our answer here is just a to the 10th. Go ahead and pause and try these next two on your own, and then I will come back and give you the answers for them. So for number 7, we need to divide first. So 45 divided by 5 is 9. R to the 6th. There's no R on the bottom, so it just stays R to the 6th. Then we have S to the 5th divided by S to the negative 3rd. So again, that's 5 minus negative 3, which gives us 8. So 9R to the 6th, S to the 8th. Number 8, we distribute our exponent. So again, I would write it down first as 3 to the negative 2 times x to the negative 4 times y to the positive 10. And again, when we have negatives, we're only flipping the parts that have a negative exponent. So our y to the 10th stays on the top, and then we have 3 squared times x to the 4th. So once we get that, we then go back and we say y to the 10th over 9 times x to the 4th, because we have to square the 3 before we can finish. So next, we're going to introduce polynomials, which is just a monomial, or it is the sum and difference of multiple monomials. So a note here is all monomials are polynomials, but not all polynomials are monomials. Just like all squares are rectangles, but not all rectangles are squares. So some of our definitions that we need here: the degree is the highest exponent of the polynomial. And next, we're kind of looking at this standard form, which looks really complex because we have a subscript n times x to the nth, and then a n minus 1. Basically, this is telling us that the coefficients are different and the exponents are going down by 1 each time. So if this was x to the 4th, this would be x to the 3rd, x squared. Then again, we have whatever's in the middle. So if this was a higher degree, then we get to x to the 1st, and our last coefficient is really just our constant. So the way we write polynomials is we write them in descending order by degree. So if they have multiple variables, we're going to order by the highest total degree first. If there are terms with the same degree, we are going to order them in alphabetical order. And then descending degree of the primary variable. This will make more sense as we get into our examples. So as I scroll down again, next we're getting into our classification. So we classify polynomials both by degree, which again is the highest exponent, or by the number of terms. So for our degree, for 0, we have a constant polynomial, because this would just be like a constant number. For 1 degree, we call it a linear polynomial. So this is like what we did if your equation is just 3x plus 5. That's a linear equation. For a degree of 2, we call it a quadratic equation. We've worked with these also. Next, we get into a degree of 3, which we call a cubic polynomial. A degree of 4 is called a quartic polynomial. And a degree of 5 is called a quintic polynomial. So if you know, these are kind of the root words for 4, for 5. We also can say by how many terms are in the polynomial. So if it has 1 term, we are going to say it is a monomial, which we have used this term at the top. Next, if it has 2 terms, we're going to call it a binomial. Bi meaning 2. Think of a bicycle. Next, we have 3 terms, which is a trinomial. Again, think of like a tricycle or a triangle. Then 4 terms, we just start calling it a polynomial. So technically, we can call any of these polynomials, whether it has 1 term, 2 terms, 3 terms, or more than 3. But typically, they will use these first 3 terms if it has 1 term, 2 terms, or 3, and then they start using polynomial more generally. So I'm going to scroll down again. So again, we're going to classify these by degree first, because we want to write them in standard form, so we have to write them in descending order. So our highest exponent is 5, so we're going to write that first, -5 to the 5th. Our next highest exponent is 3, so we're going to add 4x cubed. And then our last term is a degree of 0, so plus 1. That is in standard form because all of the exponents are decreasing. Our classification for this, again, our highest exponent, which is our degree, is 5. So we are going to call this a quintic for 5. And then let's see how many terms it has. It has 1, 2, 3 terms. So we are going to call it a quintic trinomial. Next, we just have negative 65. So writing this in standard form, we just keep it as negative 65. Our classification for this is a constant because our degree is 0. And if you're not sure why it has a degree of 0, well, really, we could put x to the 0 right next to it. And because this is 1, the negative 65 stays the same. So we have a constant monomial for one term. Then with two variables, it gets a little complex. So up there, remember I said we're going to do highest total degree first, and then we're also going to do alphabetical order. So if we're looking, this has a degree of 2. This term also has a degree of 2 because A has a degree of 1 and B has a degree of 1. This one has a degree of 2. But then as we move on, we have a degree of 3. A is 1, B is 2, so this is a degree of 3. This is a degree of 3 because we have 2 and 1. And this is a degree of 3. So we need to put our degrees of 3 first. And what we're going to do is put them in alphabetical order. So we would have a cubed first. And then you're like, well, which do I do next? Do I do negative 3ab squared or positive 3a squared b to the first? So up where we were, it said that we need to do it by alphabetical order and then descending degree of the primary variable. So whatever variable comes first, we want that one to be descending. So a cubed, let's go to this one next because that's the next highest a term. So we have plus 3a squared times b. Then we're going to go to this term. So we have negative 3ab squared. Because remember, if we're doing it alphabetical, A comes first, and then our other terms that start with A. Then we're going to put B, so minus B cubed. And then we can look over here. We've gotten rid of all of our cubic terms, so now we're going to look at our quadratics. A squared comes first, so plus A squared. Then we have minus 2AB, because remember, we have 1 and 1, so this is also a degree of 2. We have plus 2ab, and then we have plus b squared. Our classification for this, well, our highest degree is 3, so it is going to be a cubic, and it has way more than 4 terms, so we are just going to call it a polynomial. What I want you guys to try before you bring this note packet back is I want you to create a quartic binomial. If you want an extra challenge, please use multiple variables instead of just one. And one final thing before I leave this video, these down here are examples of what don't count as polynomials. So, if we have anything as a fraction, it's not going to be a polynomial. If we have something that still has a negative exponent, it is not a polynomial. If we have something that is a square root, or really this is the same as having a fractional exponent, it will not be a polynomial. Lastly, this whole term, this also doesn't have a whole number as an exponent, so it is not a polynomial.